Welcome back to the second video in my series on trying to build a 10 gigahertz beacon for terrestrial use to go up on the local repeater tower on a hill nearby. In the first video I talked about my attempt to use a Leo Bodner GPS reference clock as a beacon exciter, which I decided was not the way to go. My next attempt is to use a custom programmed DigiLO board from Q5 Signal. Thanks very much to Corey at Q5 Signal for custom programming of the board. And I had some issues with this. I got myself into trouble with instrumentation trying to check this out. My spectrum analyzer only goes to 1 gigahertz, and so I can't directly look at 1152 megahertz signals on it. So I was using a mixer to mix that down into the range of the spectrum analyzer, and it wasn't going well, and I thought the DigiLO was having problems. I didn't know why, but as usual, the 10 gig and microwave community came to my rescue and offered a bunch of very helpful suggestions, which I greatly appreciate. Thanks everyone for that. And one of the suggestions was pay dirt. I was feeding the output of the DigiLO directly into the mixer RF port, and either because it didn't like the VSWR, or maybe it was trying to injection lock, or being upset by some of the other frequencies, the LO and other mixing products from the mixer appearing at the DigiLO output, it was not locking up well. It was hunting for several minutes to achieve a lock and just generating garbage. And eventually it would lock up and settle down. But I didn't really trust it in that configuration. Didn't understand what was going on. I didn't want to use it as a beacon exciter and take a chance on it going crazy on the air. So there is a solution to that, which may not be a problem when it's driving an amplifier stage in the, or a tripler stage in the beacon exciter, or in the beacon. But driving this mixer on the test bench to look at, to go into the spectrum analyzer, it was a problem. I found a solution to that, which I'll tell you about here in a bit. So this will be a whole series of video segments that I'll edit together, showing various tests and configurations and what I finally arrived at that I'm going to try to proceed with as far as using the DigiLO as a beacon exciter. So bear with me. I'll try to make this as short as I can, but show you several things that I learned and discovered along the way, and the configuration that I'm going to proceed with, at least for now, and we'll see how it pans out in the end. If I do run into problems, there'll be further videos explaining that. In any case, there will be further videos upcoming about the beacon project as it slowly progresses. Okay, please excuse the crude clamp holding this PCB down to the bench here. This is my next attempt at a beacon exciter. This is a DigiLO board sold by Q5 Signal and Down East Microwave. This one was custom programmed for me by Corey at Q5 Signal to include a number of special frequencies in the 1152 megahertz range that, when multiplied times 9, come out in the 10368.3 to 10368.4 range, where I want a beacon to be. It also includes the standard 1152.000 megahertz frequency, which is what I have it set for right now, which would come out at 10368.0. So my spectrum analyzer does not cover above 1 gig, so I had to use a mixer here to mix the signal from this down below 1 gig. And what I'm doing is I have the signal generator set up to generate 400 megahertz as an LO frequency, which when mixed with 1152 will give me 752 megahertz. So I've got the spectrum analyzer set up for a 752 megahertz center with a 1 megahertz span right at the moment. So let me see if I can reach down here and attach the clip lead I'm using as a switch to start up this DigiLO. And it's difficult while holding the camera to get this right, but there we go. So this is on its internal TCXO, and it comes up and it's running fine. Looks okay, and it'll sit there all day and be just fine. And I'm going to have to shut off the camera for a minute, and I'll attach an external 10 megahertz reference to this from the Leo Bodner GPS reference clock here. And we'll just do this again. So I'll be right back in a moment. So here we are again with the DigiLO set for 1152.000 megahertz, and now it's connected to the 10 megahertz external reference from the Leo Bodner here. So same thing as before. Let me see if I can manage to start it up here. Whoops. It's so hard to do this with one hand, but I need to hold the camera, so I'm struggling. There we go. So it comes right up. Looks about the same as before. And it's running okay. So it actually looks pretty good this way at 1152.000 megahertz. Now I'm going to go off camera here for a minute and or shut the camera off for a minute and reprogram this for a different frequency. I'll choose 1152.04, which would put it on 10368.360, and we'll just run these two tests again. Okay, so here we are again with the DigiLO, now set up for 1152.04 or 10368.0, running on its internal reference clock. And let me see if I can fool with the clip lead here again. Forgive me, this really is crude. I didn't take the time to rig up a proper switch. And so now it comes up sort of okay, but then it goes crazy. It's not properly locked, and it's searching, trying to find a lock, and just generating garbage. And it'll do this for several minutes. It'll change around and change several times, and it'll just go crazy, and a lot of that garbage will come back again, and it'll take several minutes before this settles down into a proper signal. So I don't trust this configuration at all. Let me shut it off and go off camera. I'll connect the external 10 megahertz GPS DO reference and show you what that looks like. Okay, so here we are with the DigiLO, now connected to the external reference at 10 megahertz. Still on 1152.04 megahertz. Let me see if I can power it up here again. And it comes up, but it goes crazy again. So internal or external reference doesn't make much difference, and it will be several minutes before this settles down and achieves a proper lock. And I went through some trials trying to figure out exactly what was causing this, and got a number of helpful suggestions from the microwave and 10 gig community, and one of them was pay dirt. It turns out that I have the output of the DigiLO connected through this green coax directly to the input of the mixer, and for whatever reason it does not like that. So I'm going to go off camera here again for a minute and put a 12 dB attenuator, or two 6 dB attenuators, in here between the DigiLO and the mixer, and I'll show you what happens when I do that. Okay, once again we're back with the DigiLO on its internal reference, and the only difference is it's still on 1152.04, the frequency it was struggling to achieve a lock on. Only difference is I've inserted these two 6 dB attenuators here in line. So I've got 12 dB of attenuation in line between the DigiLO and the mixer. And let me see if I can get it started up here again. There we go. It comes up. None of that hunting and trying to achieve a lock. You do see some spurs here. Now, there are some spurs that are about, what is that, 10, 20, 30, 40, 50, about 50 dB down roughly. these stronger ones on either side, and then there's some weaker ones spaced a little further out. So, you know, 50 dB down isn't too bad. I probably could live with that. Let me just shut off the camera. I'll connect the external reference and show you what happens with that. Okay, back once again with the DigiLO, now on the external reference again, still programmed for 1152.040, and still have the attenuators in here between the DigiLO and the mixer, and I'll start it up again, hopefully. Boy, it is tricky for me to see what I'm doing with this clip lead. Bear with me a minute here. There we go, I got it. So no hunting, no struggling to achieve lock, and the spurs are still there, about the same as before. So the secret to cleaning this up somewhat was to stop all that searching for a lock business for several minutes, was to insert some attenuation between the DigiLO and the mixer. Now the question is whether anything can be done to reduce the level of these spurs. And I've tried a number of things, and one suggestion does actually work. And I will go offline here for a minute and reconfigure a bunch of stuff and come back and explain what that is and show you what that looks like. Okay. So back again one more time with the DigiLO, and it's set up a little differently now. I have the DigiLO set for 1152.0 megahertz, which with a 10 megahertz reference would produce 10368.0, but I actually have it on 10368.310 with an external reference. Now, how did I do that? Well, I've programmed the Leo Bodner over here for a slightly higher reference frequency. Instead of exactly 10 megahertz, I've gone 299 hertz higher. So 10.000299. And so the DigiLO, as far as it knows, it's generating 1152.0 megahertz with a 10 megahertz reference. But really it has a slightly higher reference, and therefore it's generating 1152.034444, which after being mixed down is 752.034444 here on the spectrum analyzer. And lo and behold, see, those spurs are gone. Remember the spurs that were there before when generating, and I should have said when generating any frequency between 10368.3 and 0.4, it had those same spurs, maybe different spacing, but the amplitudes were about the same. And this way, with this method, regardless of the exact external reference frequency chosen, and regardless of the exact 10 gigs final frequency, the spurs are essentially non-existent. So the only reason I chose something a little different instead of 1152.04 to come out at 10368.360 is that I can only program the Leo Bodner in 1 hertz steps. And this is the only one that's magic that comes out on a nice clean multiple of 5 or 10 kilohertz frequency. This would come out on 10368.310 exactly, whereas the others are all a little bit of an oddball. And the only reason I care is it's just easier for me to use a beacon as a frequency reference if it's on a multiple of 5 kilohertz, or preferably a multiple of 10 kilohertz as this is. Just easier for me to get things straight in my head and know where I am than to have to deal with, you know, a few hundred hertz off one way or another or something. And you know, I'm feeble-minded, so I need things to be as simple as I can get them. And let me just change the span here a little bit so you can see closer in. There is a little bit of grass around this, you know, around this center frequency spike. Whether that's phase noise or what, I'm really not sure. But let me just go in a little closer. We'll change this 1 meg span to a 100 kilohertz span, and there's really nothing there I'd want to call a spur. It looks pretty clean. It looks a lot cleaner than it did generating frequencies like this the standard way with a precise 10 megahertz reference. So right now I think it looks promising. I don't know what it will look or sound like on the air when the beacon is finished, but I'm going to proceed with building the W1 GHz personal beacon board, which will multiply this frequency up into the 10 gig range, and take a look at it there using an LNB as a down converter to the spectrum analyzer, and also listen to it with the LNB and SDR, and see what it looks and sounds like. And I will let you know if I find any problems with this approach. Right now I think it looks okay, and I think this might be what I end up using for a beacon exciter. But subject to further update as I progress through the beacon project. There will be more videos on this, so stay tuned. Check out any other videos in the series to see where I end up with it.